Well, hello to you all. My name is Russ, and I'm going to be taking through a series of sessions to help you learn about this machine that I'm leaning on. Now, this machine is in fact the star of the show. This is a light blade machine supplied by Scott+Sargeant. Now, I'm the proud owner of this machine, and I have to just introduce myself by saying that I'm not a teacher, I'm not a laser expert, but there are several things that qualify me for demonstrating this machine and how it works. Number one, over in the other corner of the workshop there, I have a real eBay Chinese laser machine, which I bought about 18 months ago. It took me about 6 months to get it into a shape where it was quite a reliable machine. The electrics were flaky. The tube was absolutely beyond any English words that I can describe, but the mechanics were sort of okay. So with a lot of care, attention and engineering support, we managed to get it into good shape. The manual that came with the machine was written in something which I like to describe as Chinglish. Basically a collection of English words that were randomised and put down in a book and called a manual. It didn't make any sense at all, so that was my experience. I had to learn that machine from absolutely nothing with no help, like doing a jigsaw puzzle without the picture on the box. So that's my qualification. Over the past 18 months I've learned a great deal about these Chinese machines and the technology. Now, I started off with basically a very strong base because I had run a proper metal cutting laser profiling business for 10 years and I understood the technology and the machines extremely well. Yes, this is a laser machine, but the technology is completely different. So I had to throw away all my beliefs and concepts about my previous experience and start again. So yes, I'm an engineer, yes, I have laser experience, and yes, I've now got 18 months of this type of laser experience to pass on to you guys. This machine is brand new to me, in the same way that it's brand new to you. So we should be learning it together. But I've got one advantage over you. I have got 18 months of experience with that machine over there. So that's my VW Beetle, and this is my new Ferrari. Well, I think that's enough of an introduction. Let's get on and have a look at the machine itself. Now, if you're anything like me, you'll be very impatient to get on and do something with your new machine. I'm sure that your installation engineer will have given you some basic instructions on how to run this machine, how to install your software, etc, etc. So I'll skip the very, very basics. So the first thing that we'll do is turn on this on-off button. Oh, nothing appears to have happened, but that's because we failed to let the emergency stop switch off, which somebody's accidentally leaned on. Okay, now I'll just force that start position again, because what will happen is when you switch your machine on to start with, it's the same as pressing this reset button, and if you watch what happens to the head will go to the far right hand back corner where it will stop, and then it will shuffle back to somewhere in the machine. Now what it's done, it's been over to that back left hand corner, and you can probably see that blue sensor over there. Well, let me stop for a minute. I've got a degree in beating machine safety systems, so I'm a classified idiot. This has nothing to do with anything that Scott+Sargeant would recommend. They've put safety systems on this machine to stop people like me doing this and running the machine. Now, I know how to run the machine like this. I've had to do it for the last 18 months on my other machine, but it's much, much easier to see what's going on in the machine with this lid open. We've got two sensors here. We've got this one and we've got this one at the back here. Now those two sensors basically tell the machine where its home position is, where 0, 0 is for the machine. Now I will explain what 0, 0 means to you in a short period of time, because we'll just go through the way in which this machine is basically set up. But when I press the reset button, you'll see that the head goes to this 0 position here, and the slide, this cross gantry, runs to this position here. So the machine is zeroing itself in two planes to form an axis point. And then it returns to this position here. Now this position here is nowhere special. We can move the head around by pressing these two buttons here. We can move it backwards and forwards by pressing these two buttons here. Now it looks as though it's going quite fast. You can change that speed. If you go to this button here which says speed, we get a number on here which says 200 millimeters a second. I always set mine to something like 110 or 111, just purely because it's a nice number, and I'll demonstrate why it's a nice number in a minute. So we press the arrow key and we can make that bar appear under any one of those numbers. So first of all, let's reduce that to 100, and then we'll move across and we'll make it into another. Oh, we can go up to get to the 1 and go up to get to the 1. So there we've got 111, and now we press enter. So that's a speed of 111. It's still fast enough, but it's not so fast that you have to worry about it too much. You get plenty of time to stop and think. Now there are times when you need to very accurately and precisely move the head to a position, and if you watch what happens when I press the button just once very quickly, the head jumps quite a long way. This is a very quick push. So when you're trying to accurately position the head somewhere, you will need to go back to this speed position, and what we do, we'll just take the 111 and we just reduce it to 11. Enter. And now when I press the button, look, I get very precise small movements, and that gives me an opportunity to jog the head to exactly where I want it. So there's your first simple keyboard lesson. If you leave it on 11, you will get really annoyed. So what we do is set that back up to 111, enter. Now something else I would recommend that you do fairly early on with the keyboard, you've got two powers here. One is called minimum power, and it shows on the bottom here. We've got minimum power 1 and minimum power 2. Well, we don't have two laser heads on this machine, so minimum power 2 means absolutely nothing. Minimum power 1 is probably what you need to set, and you can set that to 15%. Now I'm not going to explain why we want to set that to 15% at the moment. Just take my word that 15% is a good number. When we press the max power button, again we get max power 1 and max power 2. Ignore max power 2 for the same reason that we ignored minimum power 2. It's set to 85%. Now 85% may be fine. I don't know, because I haven't checked this tube at the moment and what its capability is. I would start off personally by setting that to something closer to 65%. So let's just change that value to 65%, enter. I feel very comfortable with 65% power. And all that again I will explain to you in a bit more detail as we go on. Because I'm going to be running this machine with the safety systems defeated, but as a precaution you need to always wear glasses. Now a laser beam is a bit like the light coming out of this torch. Can you see it? No, you can't. Does it have any effect on anything? No, it doesn't. But if you shine it in your eyes, if it went onto your retina, it would make you blind. But it depends on the frequency of the light. We're not talking about visible light. We're talking about light which is out of the optical range. Now, if it's out of the optical range up in the ultraviolet and the high end of the frequency, then yes, you could do lots of damage to your eyes. Down at the infrared end of the spectrum, we're not talking about light that looks like this. It's not going to damage your retina. Before it gets to your retina, what it's going to do, it's going to burn your cornea. So it's going to scar the front face of your eye. Now you'll see me from time to time with my head in the video, but you'll always notice that I've got my glasses on. These cheap glasses from the pound store. I mean, they're polycarbonate. You could wear normal glasses. My non-prescription reading glasses here are what I wear all the time. And so consequently, these will give me adequate protection. This is a smart set of safety goggles if you really want to look stylish. But here we've got a bog standard $2 or $3 polycarbonate safety glasses with a side shield on, you'll notice, which is excellent, which will give you complete protection. You can buy rather expensive safety glasses for working with these laces. Personally, I wouldn't waste my money on it, even though my eyes are very valuable. These will give me adequate protection. And so what I'm going to do is just give you a quick demonstration. Right, I've just put my reading glasses directly in the beam, and what I'm going to do is just going to pulse it so that you can see what happens if you accidentally got your eye in the way directly of the laser beam, which is a virtual impossibility on this machine, but just in case, here's what will happen. Okay, let's do it again, and again, and again. If you had a fire in front of your eye, I think you'd move out the way fairly quickly. What I'm saying is, it hasn't burnt through. That's the level of protection you'll get. This laser frequency is fully absorbed by this material. I can do exactly the same thing with our safety glasses. Polycarbonate again, so we don't expect any different. And it still hasn't burnt through. Now if you wear real glasses, I will just do the same demonstration for you. And you'll see it's having zero effect on the glass because it's being 100% absorbed. Well, in a future session I shall be tackling in more detail the risks associated with the laser beam, what the properties of the laser beam are, and we'll be talking about the laser tube itself, how it works and how you should be careful and look after it. Look after it well and it will serve you well, but if you abuse it, it'll kick you in the pocket. I have just plopped a piece of plywood in here. Right, now I haven't set this distance here to anything special. At the moment it's probably something like about 50 millimeters. This thing here, I think the system calls it a pen, but basically it's a micro switch, a sprung loaded micro switch. Basically what that does, that goes down and it senses this surface and will automatically set this to the correct height above the work. Now I'm not going to do that at the moment. We'll talk about that in a completely separate session, the autofocus system. At the moment all I'm trying to do is just quickly do what I said, demonstrate the machine. So I want to see it doing something. So I'm going to press the pulse button now. Oh dear. What did you see? Round at the back of the machine here, we've got a little air pump. And I'm just going to power that on. And there we go. It's not too noisy. We'll move the head slightly. And we'll do the same thing again. And see if you notice the difference. Now, that's just a single pulse on the button, with me just going bip on the button. I'll just turn the air pump off again and do it one more time. Watch this time and you will see a stream of smoke appearing to come out of the end of the nozzle and down to the wood. Now I'll turn the air on and do the same thing again. What you see there is one of the reasons why you should always make sure that you have your air assist on. When I did it without the air on, the laser beam was actually, or the smoke was bouncing straight back and going up, potentially into the nozzle where the lens is, and you could be fogging the lens or making the lens dirty, which will change the efficiency of your machine. So whenever you run your machine, please, please, please turn your air on so that you can see clearly here one more time. When I've got the air on and I press this button, can you see the smoke just disappearing out of the way? It doesn't go backwards at all. Now on the machine we also have a milliamp meter, and when I press the pulse button again, I just want you to watch what happens. The current goes up. Now typically for a 60-watt tube, which is what I've got in this machine here, you would not want that meter to go over probably about 22 milliamps. I will have to look up, because this is a brand new high quality tube, the manufacturer of this tube may allow me to go up to 24 or 25 milliamps. I don't know, I shall have to look that data up. But I know to be absolutely certain that typically 22 milliamps is the maximum you'd want to put through a 60-watt tube. There are specified values for all tubes, but different manufacturers may well allow you to go a little bit more than that. Again, another important feature that we shall come on to later. Don't overdrive the tube by going more than the manufacturer recommends. Well, that's, I think, enough of a quick look inside the machine itself. We've satisfied my curiosity and we've actually burnt something. And if we take a look around the machine, you'll clearly see that it says everywhere, Class 1 laser product. Avoid eye or skin contact exposure. In a future session we'll talk about the various dangers of laser. The good thing about this machine is you're not exposed to any danger if you stick within the rules that are written down and you don't do the silly sort of things that I'm doing, which is beating the guard systems. Things like this door, you need a special tool to undo the door to get access to these various things. Now what that does mean to say is you could come in here. This is not door interlocked, these panels, so you could come in this way and get yourself exposed to the laser beam. Again, we'll talk further about that later. Now here we are at the back of the machine, and again, you would not normally be able to do this, but just understanding my degree in beating the systems, we can have a look at the laser tube itself. Normally, if that door is open, you would not be able to fire the laser tube. But what I'm going to do is I'm going to pulse that laser so that you can see the laser actually working. And there we go. Nice pink beam. I mean, one of the reasons why they don't want you coming in this cabinet is because down the end there's 25,000 volts DC. That's like lightning. It's well protected, but it's still potentially dangerous down the end of the system. So let's just zoom in on the working end of the laser, which is this end here. Then I may be able to hold that there and do this. Now, you saw that. That was the laser beam coming directly out the end of the tube, burning a hole in that cardboard, producing a flame as you saw. This is basically a dangerous system, and that's why it requires to be fully interlocked to prevent you getting in there doing any harm to yourself. Now I'm going to keep stressing that point because I break the rules. You mustn't. That's enough of a taster for how the machine works. We will get into further parts of the machine at a later point in time, but what I'm going to just do now is to very quickly introduce you to the software system that runs this machine. Just behind the machine you'll see that I've got a Stone Age computer which is running a Windows XP system. It's a 32-bit system. Perfectly powerful enough to run this software, but the software will run on a Windows 10 machine, 64-bit Windows 10 machine as well. So it's a very flexible piece of software. So there are three ways that you can control the machine. You are supplied with a cable, a USB cable, which is a male-male cable, which goes in the back of your which goes into the back of your PC, and then goes into a socket on the side of the machine here, a USB socket, and it's clearly marked data line interface. Now that's for if you want to control the machine from a computer. you don't have to run the machine from a linked up computer. The machine doesn't need that computer there to run it. Believe me, I'm in a, as you can probably sense, a fairly cold workshop at the end of my yard. Now, this is not a heated workshop. Most of you guys will either be in a laboratory, in a lovely factory, possibly in a school, who knows where you are, but I can guarantee it won't be as cold as this place. So come the winter months, I'm not going to be sitting out here programming, I'm going to be inside. Now there's two ways that I can be inside. I could, if I wanted, have an Ethernet cable. Now down in this cabinet here we have the main control system. It's all beautifully wired, and this is the main controller for the system. This is the Ruida controller. Now, coming out of this controller, we've got these two sockets here. These are extensions of these two sockets here. And there is a third socket on there, Ethernet. So you can control this system from a network. At the moment, this particular machine is not wired up to take a network because I don't need it. But if you needed to run your system on a network, all you need to do is ask ThinkLaser and they will ensure that that connection comes out somewhere where you can plug an Ethernet cable in. As I said to you, this workshop gets rather cold in the winter, so I'm going to go inside to my office now and we're going to take a look at the programming system on my rather nice warm indoor office. Okay, welcome to the warm office, and the first thing we're going to do is load RDWorks, and I want you to check up in the top left hand corner and you will find a version number up there which is V801, and then there's an 18 or a number after. Now that's the issue number of the software. I would earnestly suggest that you only get your version of software through ThinkLaser. Check what the latest version is if you like on the Ruida website, but get your version from ThinkLaser. And also there will be a manual that can be obtained from ThinkLaser. Now the manual that I had to work with was unreadable, but through the efforts of quite a few guys on a forum called www.rdworkslab.com, and in conjunction with ThinkLaser, they have worked together to produce a very readable version of the original manual. In a strange sort of way, that almost makes my job unnecessary, but I know that many people like to watch rather than read, and also we may well have some more tricks here that we can look at rather than read about. One thing I would like you to notice is that I'm speaking about ThinkLaser in the third person. That's because I'm not a ThinkLaser employee. I have a ThinkLaser machine and I undertook to do a series of videos for them for training purposes. So that gives me the freedom to provide you with completely unbiased training and comments about the machine that I'm using. So back to this version, there are two ways that you can install it. You can install it on a PC that is hooked up to the machine via the USB link, and in which case you will find that some of this configuration will already be done because the machine is talking to this software. In this particular instance, because this is a remote PC, there's no connection between it and the machine, and so I've got to configure it manually. Now that's not such a bad thing to watch me configure it manually, because you may well want to go through and check that the configuration on your PC linked to the machine is configured correctly as well. So the first thing I want you to notice is that in this top left hand corner we've got two arrows, two blue arrows. That represents the 00 position that the machine runs to when it starts up. Now, as you've already seen, that isn't the position that the machine runs to for the light blade machine. We need that to be over in this top right hand corner. Now, I'm not going to explain why at this moment in time. We'll deal with that in another session,
But what I'm going to do is ask you to go to the config system settings, and here you will find that you've got two controls or two boxes called mirror. One is for the X and one is for the Y axis. For the light blade machine, both should be ticked. Now there's one other thing that you need to do on this page, and that's make sure that this dot is in the top left hand corner. Now I say make sure. Let's put it there for the time being. You can decide where you want it once you understand what it does. Close. Okay, now I want to drag your attention down to this bottom left hand corner here, where you'll find that there is a little green square. It always puzzled me when I first saw it, but let's just show you what it does and how it works. First of all, we'll go up here and we'll place the arrow over the ellipse tool, and we'll click the left hand mouse button and bring it onto the work area. Now I'll hold the left mouse button down and I'll drag a shape. It can be an ellipse, but if I, at the same time as holding down the left mouse button, I hold down the control key on the keyboard and move the mouse, look what happens. I've constrained the ellipse into a circle. Keep the control key pressed down and release the mouse button, and the circle remains a circle. Hello, why is that green square sitting up there top left hand corner? Let's use the marquee, the Windows marquee, and we'll put handles around that. And equally well, by the way, escape. If you really want to be fussy, you can touch on the object itself and click, and that will put the handles on. What you'll notice is that the green square is hanging on the top left handle of the circle. Let's confuse the situation a little more, and we'll put a square or a rectangle in there. Now what's happened to the green square? It's not on the handle of the circle, and it's not on the handle of the square. But what it is on is a handle of an enclosing a rectangle for both objects. Let's not get too concerned about what that green square actually is and doing at the moment, but I just wanted to show you that the green square can move around in a rather strange and erratic way. So we'll put rectangle on there and we'll delete that, and we'll bring ourselves back to the circle. You will notice that the blue arrows are now top right, and that is set. Though changing those two mirror commands has set the arrows into the right position for us. Okay, top right hand here, we've got a black layer. Now that's because we've got a black object. If I put handles around that object and I go to the bottom here where I've got a coloured toolbar, I can select, for instance, the red, and that object has now become a red layer object. And hang on, the layer up here has changed to red as well. Let's double click on that layer, click, and we open up something called a layer parameter window. Now basically this is how we're going to program this circle into a manner that can be read by the machine to draw that circle. So let's go through it very quickly. Nothing very complicated at all. Is output yes? I'll explain that later. Speed 200 millimeters a second. We've got the choice here of scanning or cutting, dotting or pen. Well, we'll just go for cut. And here we've got two numbers, which minimum power and maximum power. Now we can't ever untick that box because that means the laser head wouldn't work. We've got one laser head and we need it working. But on the other side here we've got a little box called default. If I tick that box, look, all of a sudden I don't have any control over the minimum and maximum power. Now if you remember 10 minutes ago when we were out on the machine, I set the minimum power to 15% and the maximum power to 65%. By choosing that default, I have now opted to let the program run at the default values that I've set on the machine. I don't want that. I want control of those values. So I would generally urge you to untick that default button if it is there and keep control yourself. Now for cutting, generally you will have the values set to the same value. Don't choose different values. Generally different values are for the scan mode and not for the cut mode. I say generally because there are exceptions, which again we will touch on as we get further into these sessions. Now there's one other thing down here which looks as though it's working, which is this 50% through power. It's not working at all because we haven't got it ticked. Laser through mode, if I tick it and then untick it, you'll see that it actually disappears. It's not working. We'll just say OK, and that's it. We've written our program. Where's the machine code? I don't care. I never see it. I don't need to. All we've got to do now is get it from here out to the machine. We don't have an Ethernet connection to this PC, and it's certainly not connected up via a USB cable. So now we've got to look at the third way that I discussed when we were out in the workshop. And the third way is actually using a USB stick. The very first time we've got to come down here and we've got to make sure that this device is configured to USB automatic. You can then go to this here, which is save to U file, and we can click on that. You'll see that the file type is .rd. So I'm going to save this as circle. See, I would advise you to make sure that you don't use long file names because they will be truncated to about 8 characters. Okay, now I've saved it, it comes up with this rubbish which looks like a warning. I think it says have a nice day. Okay, I've just saved a machine code file. I can't read it, I can't do anything with it, I can't reload it into this system and recreate this drawing. If I want to save this drawing, I've got to do just that. Go up to the file and press save as. And now I can save as circle RLD. What that means now is I can close this system down and I can reload RDWorks, and so I can now open up circle, and there it is, we've got it back again. So that's how you save something for future use. But remember, we've just saved something to a U file. So let's go out to the machine and see what we can do with that U file now.
Well, back at the machine, memory stick, USB, data port. We're going to plug that into the USB port, and I like to show you all of the keyboards so you can watch the key presses. Because what I'm going to do now is press file, and we get the opportunity of all these options down here. These are files that are already been loaded into the machine, and we've got this second one down here which is called UDisk, and we get that by pressing this key to get the highlight across to there, and then we move down to UDisk, and that's basically going to read this memory stick. So we press enter and it gives me various options that I can do to the UDisk. I can delete files from the actual memory stick itself, or I can copy the files from the disk, from the memory stick into machine memory, but I can't do anything at the moment because I've got no files. So the first thing I've got to do is read what the memory stick says. So read files, and there we go. Now one of the files that we find there, we can use the arrow keys and we can get down to circle, and now we're down at circle. We've got to go across again, and now we've got to come down. It's a bit convoluted, and then we eventually get to copy to memory. Copy successful. Enter. Nothing appears to have happened. Press the escape key and you'll see that our circle appears in this little window. Press the enter key again and you'll see that we get our circle appearing here. Now if we press the enter key again and again, we get an opportunity to actually modify the cutting parameters here on the machine. And we can do that by pressing the ZU button, and if you watch what happens with the ZU button, it will send me down and back to here, where if I had multiple layers I could use these keys to get different layers. but as we've only got one layer, we will just step down one more time with the ZU button to 200 millimeters a second, and we'll change that to 150. Okay, now bear in mind my base program back in the office is still 200 millimeters a second, but I'm going to edit it on the machine here to 150 millimeters a second. Enter. Now I can go down and change. We've got this is something you need to remember when you look down this list. It's minimum power and maximum power. Quite often you can get mistaken and you can put maximum power and minimum power. You think that's the way that they are, so read them very carefully. Now we're happy to press the enter button. So we press the enter button now. Setup success. Enter. Now what we need to do is to decide where we're going to put the program on the table. So we'll use the arrow keys at the moment, and we'll drive the head over there to that rear corner. Ish. It's not that important where it goes, but I'm just putting it there just for the moment. If you remember, we had a green dot, a green square, and then we had the handles around the circle. That green dot is where this head is. And now what I'm going to do is to press this key here, which is the origin key. What that's done is created a new 0 start position for the job. And so now when I press the run button in a minute, it will run from this position here and draw a circle. Before we get it to run, we can do a check. There's something here called frame. Now if I press the frame button, we shall get basically a preview of the enclosing rectangle or square. But it will always go back to that origin. So let me just do this one more time. I'm going to press a reset. Now remember that a reset sends it over to 0, 0. And then after a reset, it will come back to the origin that you last used. There we go. So even when I switch the machine off, it will always come back to that last used origin. Okay, now I've got this completely set out of focus. I'm going to be drawing a thick burn line. It won't be a thin burn line, but it will just be to show you what's going on. So I'm now going to press the bottom right hand button, which basically says start or pause. I paused it halfway through, and I'm going to press it again, and there we go. So you've seen all sorts of things today. We've burnt our very first program, and I think, to be honest, that's a very convenient point to stop.